Hello everyone. In this demonstration flow, we are going to illustrate the data fabric part of aerOS. So for that purpose, we are going to use the aerOS management portal in order to create a couple of data products that will establish some data flows that will collect data from a real car that is moving on the Democritus premises. So this car will produce some data that will be injected into the aerOS data fabric and then will be used by a couple of services. As you can see, before starting the flow, this is the data catalog view of the management portal. Here we have an already created data product that is named LDAP. This is owned by Cloudferro. It has been deployed in the Cloudferro domain, and it includes some glossary terms that are related with the aerOS continuum data model. For instance, if we click in this URL, we will be redirected to the ontology specification of this ontology. So now, Andreas, please, it's your turn.
Of course, I will share my screen right now. Okay, can you see?
Yes.
Perfect. Now we will deploy the two services, which is 5G car applications, which gather metrics and sensor metrics, 5G data like location, geographical altitude, longitude, and etc. And will be propagate those data in MQTT broker, which is the other service, and they will be deployed in the Democritus domain. As you can see, we have also the 5G car, this one. I don't know how to full screen. Yeah, that's the car.
Module, the sensors for the distance, for objects, also has the capability to be navigated, working on machine, on the motors, and collecting data to push to the data fabric where they can be used by other agents or applications remotely, locally, or remotely across the continuum. So, just please continue.
Yes, I will continue. Now we'll deploy the two services. Let's create a name for the component. Okay, we have two service components. The first one is the main application, which receives command from MQTT topic from Node-RED, and they can start moving, as we will show cases later. We deployed it in NSRD domain. We will choose the Raspberry Pi, which the application will run. We'll create also network ports. I think the right one. We also have environmental variables, so the application to connect to the Mosquito broker to exchange messages, like the broker name. the broker port, the topic that it will receive messages, so it can move, and the topic that will send the metrics, so we can showcase them in Data Fabric. Okay, save. Okay, as you can see now, the service is deployed, and we received also in the portal 2 new notifications that those 2 service components have been deployed in NSRD domain. As you can see also here in the domain, we have the car application that it's running on the Raspberry Pi, the infrastructure element that we selected, and the Mosquito broker in the other infrastructure element that we also selected. Now we'll continue with the creation of data product. Rafa.
Okay, thank you, Andreas. So Rafa now will go for the data product. At the moment, we have deployed our service components in the continuum, which produce data from the car, gather metrics, and are ready to receive navigation commands, and they publish to the broker, which are consumed now by the data product and the pipelines that will be deployed from the portal in Cloudflare. And Rafa, please navigate us to this procedure.
Okay, thank you, Vasilis. So now I'm going to create through the management portal a couple of data products in order to inject the data retrieved from the car into the aerOS data fabric. Okay. So the first data product will retrieve telemetry data from the car and will insert it into the aerOS data fabric. So for this data product, we are going to use an streaming data product from MQTT sources. So now I'm going to fill in the details of this data product. This data product is owned by Democritos and it's also deployed in the Democritos domain. Okay, and I'm going to use these glossary terms because we are using the vehicle data model from the Firewall Smart data models with this identification tags. From the MQTT topic card data. And for the host, I have to insert the service of the component that Andreas has deployed before. These mappings files and without any translation files. Okay, so as you can see, we have created properly first data product. And after this successful creation, we are going to create another data product that will retrieve the same data from the car, but it will be used then by a Kalman filter based function that will be run using the aerOS embedded analytic tools. Okay, so as before, I'm going to fill in the details of the second data product. Be also deployed in Democritos.
Yes, thank you, Rafa. Give me a second, please.
it will retrieve the data from the same MQTT server that was deployed before by Andreas. And the main difference is that this data product uses a translation file in RDF format. So after filling in the proper information, the data product is created and also displayed in the data products view. And in addition, we can also filter the data products in order to have a proper view of them. So thank you, Andreas. Now is your turn again.
Now, as Andreas is preparing to showcase the use of this data federated over the continuum based on the data fabric pipelines and the capabilities of aerOS data fabric, we'll explain that the data that are pushed from the card to the broker are consumed by the product data pipelines that were created by Rafa just before, and now they are federated all across the continuum, and they can be used in all domains that are subscribed in this federation to build applications on top of this. One of these applications we will demonstrate now, and is based on the low-code tools suite that aerOS has integrated, and will not use the Node-RED application to consume data from the continuum and to present what data the car is sending, and to send back navigation commands, controlling commands to the car.
Now we will proceed with the navigation of the car through the Node-RED application, which will send commands in the Cloudflare domain, and through Orion data fabric will read the commands, and the car will start moving. So we enable it. We can see that it's false, so it's not moving. When it becomes true, it will start moving. We activate it. And as we can see, I don't think Vasilis. As you can see, it starts moving. And if we change the direction, it will start moving from that side. It's we try to turn it now. Okay. If we patch to stop it, it will stop now. As you can see, it stopped. It stopped. And this is how the data product pipeline works.
And here is the dashboard for the embedded analytics tool. So at the moment we have 3 functions running on the embedded analytics tool. One of them being our demo vehicle prediction function. So what this does is retrieve information through the Kalman filter and visualize it through the Grafana tool. Through the function, we are exposing a CSV which produces the latitude and longitude and predictions for the car which is running on the roof, which we have just seen. We can access this information by triggering a function here. So we can pass in the location of the function, and we can check the CSV which is produced. And here's an output of the file. So here's just a 5-shot sample of what we would see in this case. To move back then to the tool, we can also visualize this. So we can step over to our Grafana, where we can see here, we have a visualization of the map where the car is located. And we have symbols here which are indicating the measurements of the car as it moves across. This is all connected up and passed through the Orion context broker. So as the car moves around the roof, this is all updated in real time. We can refresh the dashboard here, and we can see now that the car has moved. Can't zoom in too far because of the map resolution. We can see now that the car has moved to the corner of the building and has stopped moving. We also have two other functions running as part of the embedded analytics tool. We have a HLO explainer. I would just highlight the invocation count. So for the duration of this video, we have been leaving the function running in the background. And as the services were coming online and the service was being built up, this invocation number was going up, which we can also see now that it's still going up, meaning that the Mosquito is still transmitting data over towards the embedded analytics tool, which is then in turn being visualized through our map. In parallel, we also have a HLO explainer. This has also been triggered in line with the demo. So as each service, a new service is being initialized, we're generating an explainability function which works in line with the deployment of services. We also have a visualization of this in Grafana, so we can move back to our home. We can go to a dashboard. On the deployment of the function, a dashboard is created in parallel. So we can see here from our HLO dashboard, we've generated a graph, which is our explainability for the service deployment. What this shows is the importance of the features when making service decisions. So in the last service that was deployed, we can see that node 70 bandwidth, node 68, and node 51 real-time node 92 were major contributors to the decisions made around that service deployment. And finally, the EDA report. So what the EDA report allows us to do is visualize data collections in our Orion LD. So through this again, what we can do is we can take the function and we can generate the output HTML for that function. We have no EDA generated, so I can trigger it with this one. So the EDA generation, so what this does is it takes a data set. We can see it here at the bottom. So here's a sample of a data set. This is looking at the latitude, longitude, date, UTC time, a number of different variables that are related to the car. And it visualizes it in a meaningful way. So we can see in a handful of alerts issues with the data. So the data is highly correlated with the signal quality. We have the latitude is correlated with the longitude. We can see these kind of things that we would expect from a car moving around on a roof. But then we can also visualize it in different ways. So we can specify specifically with the latitude, and we can look at how it compares with the other data sets. And this again is all visualized through the embedded analytics tool with the help of Grafana in parts for the functions. So I can give back to you, Rafa, if you want to tidy it up.
Okay, thank you for this explanation, Joe. So after the demonstration of the outputs of this function that was run by the embedded analytic tools, we have finalized this demo flow in which the creation of data products and the consequent flows of data were demonstrated.
I think it was, yes, overall it was a very complete flow and showed how do we deploy the services to domain, produce data, push the data, translate and transform the data based on the pipelines that we build from the portal, deploy the product in the domain that we want and search the catalog, have the pipelines, share the data, annotate them as needed by different applications. And we show that we also build an application, both build an application that can run on top of this data and produce navigation, control, and command and control over the car. And also, how do we use the better analytic tools and the data analytic and the open fast and to be triggered on events and use this data to provide meaningful analytics and statistics and the visualization of these cars based on the rich tool set that we have in our embedded analytic tools in all aerOS domains.